So, in the next series of the videos about soil, we are going to talk about moisture in the soil today. Ever walked past a field on a super hot afternoon and seen that air shimmers above the ground? It almost looks like the earth is glowing. What's going on there? It's mostly because the air just above the hot ground heats up too quickly by the sunlight, and this rising hot air bends the light, causing a shimmering or mirage like effect. But there is the interesting part. Some of that rising air also carries hidden moisture from the soil. Let's dig in to find out how this moisture comes in the soil. So, even when this soil looks dry, it's never completely dry. If we zoom in, we would see that there is always some water trapped in between the soil particles as the capillary water. Capillary water. This hidden water is what we call soil moisture. On hot days, it slowly evaporates, rising into the air. Some students believe that moisture comes only from rain, but that's not it, because it also gains moisture from dew, it also gains moisture from humid air, and from groundwater seepage. All of these combinedly factor in for the moisture in the soil. Even powdery or dusty soil can have invisible moisture hiding inside. But wait, so does only farm soil have this moisture? Well, no. Let's prove it with a safe experiment you can do at home as well. Let's call this activity as detecting moisture in any soil sample that you can. For this, you have to take a few amount of soil from any potted plant at your home or anywhere around you. You have to place that soil in the steel bowl, and you have to cover it with a cool metal or glass plate. To make it cool or colder, you can mix it with the cold water if needed. Now you heat this soil bowl gently using a low flame or a warm sunlight. Here in this activity, I am doing it over the flame under the expert supervision of my mom. So I suggest you do the same. Now, after putting it for heating, when you wait for a few minutes, you will see that there are tiny droplets of water condensing under the plate. Wait, let me show it this way. As you can see, that droplets of water are condensing over the plate. That is the moisture inside the soil, now escaping as vapor and cooling on the plate. In this particular section of video, you can see that vapor coming out of the soil. Again, that is also the proof of moisture being present in the soil. You can try this experiment with different types of soil. Once you do that, you will see that not all the soils hold the same amount of water. All the soils, all the different types of soil hold the different amounts of water depending on, one, the size of soil particles, and two, the gaps between them. Try to understand this from this picture. So consider the soil that has large particles. Soils with larger particles, for example sandy soil, it will have larger gaps between them, which again helps the water escape them quickly. So since the water escapes quickly, the soil cannot hold the water very well. Quite opposite to it if you think about the soil with fine particles, which is clayey soil. Since they have tightly packed soil particles, fine particles, they can hold the water between them, they can trap the water molecules between the space. So such clayey soil can hold the water very well. Now, if you have seen the previous videos of us about soil, you would have seen soil percolation, where I also explained the difference between the absorption and the percolation. So if you really think about this, this is exactly what we are talking about. We are talking about the absorption of water in the soil. There we studied how we can measure the percolation rate of the soil. Here we can try to measure the absorption of water in the soil. For that, again, you can do a particular activity. For this, you need to take 100 grams of dry soil in a bowl. In the previous activity, we took a random amount of soil, but here for the experiment of measurement, we have to take this specific amount of soil. Let me write soil here so that people don't get confused. As a next step, we will add water slowly, very slowly, until it just begins to leak or form a puddle in this. So when you add water till it begins to leak or form a puddle, then you can measure how much water was added in this particular amount of soil. For that, you can use this formula. Percentage of water absorption is equal to water added, that we will measure in milliliters, divided by the soil weighed, which is in gram, multiplied by 100. So for example, we took 100 grams of soil here and we saw that, for example, 27 ml of water went into this 100 gram of soil before it started making puddle. So percentage of water absorbed here would be 27 divided by 100 multiplied by 100. So 27% would be the absorption capacity of this particular soil sample. You can try this with different soils, loamy, sandy and clay, and compare the results just for fun. Just like percolation, moisture also plays a big role in the characteristic of soil and its impact on the life. Why soil moisture matters? It feeds the plant roots. This also helps farmer choose the crops suited for the soil, just like the percolation does. It also tells us how much irrigation is needed in the given soil sample in the given region. It even affects how water moves down to become groundwater, because only after soil is moist enough does the extra water start percolating to recharge the water table. So basically, just like percolation too, understanding how much moisture can soil hold, it helps us plan better, especially in the places where water is precious. In such dry regions where moisture can be limited in the limited amount or in the scarce amount for the soil, you can plan your agriculture better, you can plan your building structures better. So just to summarize, firstly, soil always contains some moisture, as we saw, even when it seems dry. We saw this on a very first-hand basis performing the particular activity. And as I said, you can detect this moisture using heat and a cool plate. Different soils hold different amount of water, and you can measure it with a simple activity and a formula that I provided in this video. Soil moisture matters a lot for farming, for water conservation, and for planning and structurizing the life around whatever soil that you are living on. So next time you walk barefoot across the ground on a hot day and feel that warmth rising through the soil, remember, it's not just heat, it's moisture escaping quietly, drop by drop from deep within the particles of earth. Moisture that maybe once nourished a plant, or could have fed roots or soaked down to refill the well. It may be invisible, but every grain of soil holds a secret, and every drop of water it holds matters more than we often realize. Stay curious, stay connected, and keep learning science. Thank you.